Good evening everyone, myself Gautam Sharma. I welcome you all in Sapiens Education. So today I am going to discuss about the part 8 video, and here we will go for the combination of the lenses. So combination of a thin lenses, okay? So before that we need to understand what is power of lens. What is power of lens? Power of lens. So let us consider there is a two lens. There is a two lens, one is thin lens and another is thick lens. When we observe that when a light, so what happens, there is a thin lens and then there is a thick lens. So let us consider a ray of parallel beam of light. When it will come, so it will definitely able to converge it, right? But when we talk about this, so it means that it is your thick lens. So when a ray of light will pass parallelly, so it will converge more like this. So what do you observe? That it has converged more. See here, let us consider theta 1 and let us consider theta 2. We can observe from here that theta 2 is greater than theta 1. It means that it has more converging power. It has more converging power, right? So it means that the power depends upon the focal length. So it has focal less. If we talk about the focal length, it has less focal length. It has more focal length. So from here we can infer that power is inversely proportional to 1 by focal length, or we can say that power is equal to 1 by f directly. Okay, so this is the definition of the formula. As more focal length, less convergent, less ability of the lens to change its path, but less focal length, more bending capability it has. That's why power is inversely proportional to the focal length. Now we will discuss about the combination of the lenses. So there are several lenses. Let us consider, we can take a two lenses. So this is a principal axis. This is principal axis, and there is a lens like this, and there is another lens like this. Got it? Let us consider it has a focal length f1 and it has a focal length f2, right? Now let us place some objects. Let us place an object. So let us consider there is an object at this point, which, and it has an object distance of u, and this is optical center 1, and this is an optical center 2, and this is an object. Now a light ray is coming from the object. So what will happen? A light rays a light rays coming out of the object. Okay, let us. Okay, yeah, this is the light rays. It is going like this. Okay, now what will happen? It will bend. So let us consider, due to this, what happens? It bends. So suppose there is no lens. There is no lens, or just I'm telling you that just erase it. It will be better. It will be better so that you can understand. Now light will form an image at this point, and this can be considered as I dash, and the image distance for this can be considered as v dash. So this is the image, right? Got it? Now the equation we can write from this as per the lens equation. So 1 by f1, because it has a focal length f1. So this will be equal to 1 by v, that is 1 by v dash minus 1 by u. So this is equation number 1. Now let us understand that if we keep another lens of different focal length. So let us consider we have kept a lens of different focal length. So let us suppose this is focal length 2 and it has C2 center of curvature, and now what will happen when you place this? So what will happen, this image will act as an object for this lens. So what will happen, it will try to bend it more. So finally we have got an image I. So if you talk about the image distance, so this will be v, image distance, this will be v. So basically we this c1 and c2 are very close to each other, so we are taking v as a from this center only. So this is a v. Now for lens 2, so earlier for lens 1, so this is lens L1, this is lens L2. So for lens L1, 1 by f1 is equal to 1 by v dash minus 1 by u. Now 1 by f2 is equal to 1 by, for this 1 by image is, this one is the image distance, so we can write here b 1 by v here, minus 1 by object. So object will act as a I dash, so definitely object distance will be v dash, right? So this we can write. So this is equation number 2. Now combine these two equation. Combine these two equation. If we combine these two equations, so what you will get? So 1 by f1 plus 1 by f2 is equal to 1 by v minus 1 by u. 1 by v minus 1 by u. So we can write here 1 by v minus 1 by u. Okay. Now we want combination of these two lens. Means, see, we want this lens in such a way that it will act as a single lens. So can we consider this whole lens is acting as a one? So can we consider this as one? So this both combined form of lens will have a focal length, let us say f. So for this combination of lens, the object is u or o, which has object distance u, and image is I, which has image distance v. So can I tell that for this focal length 1 by v minus 1 by u can be written as 1 by f? So can we write this? So definitely we can write this as a 1 by f, and this is equal to 1 by f1 plus 1 by f2. Okay. So finally what we have got was 1 by f is equal to 1 by f1 plus 1 by f2. This is the formula for the combination of lens. Now if we have multiple lenses, then focal length will be, or total focal length will be 1 by f1 plus 1 by f2 plus 1 by dot 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 fn. Okay. So in this way, now if there is a concave lens, it may happens there is a convex lens, there may happens there is again concave lens. So you have to use a focal length with the symbol like negative for concave and positive for convex. So then only you will able to get the proper focal length. So I hope you have understood this. So I hope you have understood this. So next topic I will come for the next video. Thank you for watching my video.